attended the previous lecture because now we are gonna get back to the example which I provided on the previous lecture, and we are going to add some kind of a layers to it, go in depth of the technical details. And on the previous lecture, I promised you to upload the code snippets, but I decided that we will keep going with the examples I provided. And by the end of this day, I will add comments to it, make it look fine, and then upload it to the GitHub and share the link in the Discord. So let's head back to where we stopped. And the first thing I want to clarify once again, we all agreed that the functions are just an objects. And here I'm showing you the methods of how we can operate with the functions, similar as we would do it with the objects. So basically we have a function, we saw that example already. And what am I doing here? I'm putting my function inside of an array, and then as simple as that, I'm just calling by the zero index because it's the first element inside of an array, adding parentheses, and it's pretty much works correctly. The next thing I want to highlight is that we can easily add properties on every function, same as we do with objects. So here I have just an object, empty one, and then I'm just saying that some object will have some property, which value will be just property. I don't know, I'm not that creative to come up with some meaningful names for the example. And the same I can do with functions, so I declare the function, pretty much simple one, and I can set its property to something as well. So same as I go with object, I can say that some function will have a property of something, and if I console.log that, it will actually give me something. So based on what we learned, based on the functions being objects, we can easily make an assumption that we can pass a function as an argument to another function, which is pretty much a logical statement. So I declare the function here, which just console.logs Krista, and here I have a function called higher order function, and it's not a random name. So higher order function is a function which may take or return the function from inside of it, which takes function as an argument or returns it. So basically, here I'm trying to pass function inside of it. When I call higher order function, I'm passing say name, which was declared here, and then inside of that function, I'm calling the one. Why callback? Because every function which is passed as an arg is called callback function. So basically, if function received function as an argument, it's higher order one, and if it's passed as an argument, it's called callback function. But in this example, we cannot really say why do we need it, because it's just an example. I could call a higher order function. So I could call say name just by saying say name, and it would give me the same result, because the function which I provided here is just instantly called, and it's absolutely the same to call it with the function itself. It's pretty much unneeded. It's just for the explanation purposes. But here we can actually see some useful example. And what I do want to do here is declare a function, which is pretty much the same function. Let me comment out everything which was before that. And here I am creating a wrapper function, which is count calls. And what I'm expecting here is to know how many times our function was called. Here in our wrapper function, I'm providing the function itself. So I'm expecting some function to enter as an argument here. And then I'm returning the function. So make sure, as I said, higher order function is which takes a function as an argument and which returns it. And this does both. So it's definitely a higher order one. Here I'm trying to return a function Note that our function is at the right side of the statement because return goes first. So it's basically function declaration, and that's why I don't need to provide a name. It's just an anonymous function. And make sure that you understand that anonymous, I'm not sure if I write that word correctly, but is a function which doesn't really have name. It has more academical explanation, but from this point, anonymous function is just the one which is just returned. It doesn't have any name and it doesn't have to be called from anywhere. So basically the logic is this. We have a property count calls, and it's the property of our wrapper function, and it sets itself by 0. So for now, it's just a 0. And after I return the function, every time when the inside function, this function, is called, I am increasing the call times by 1. It's pretty simple example, and the good part is that in the return section, I'm returning the execution of the function which I was passing. So basically, if I say const, here I want to have this function. So basically, I don't need my wrapper. It has to be called just once. But this function has to be declared somewhere because we have to call 2 parentheses on it. In other words, I must be doing this. So just doing 2 parentheses to make this function execute. But I'm doing it by the const, and I'm saying that say name with count calls will equal to count calls, which is the wrapper function. And here I'm passing say name as the argument for our wrapper. And then our function is returned. So for now, this variable holds the data of this function because that's what was returned from count calls. So basically here we are holding the data of this function. So what am I expecting here is to we don't have any arguments here, as you may notice, and we are trying to count how many times our function was called. So on every every calling of the inner function, say name with count calls, we will actually increase our count calls call time. So for example, if I run this file, JS, both of them says Krista because we have console.log Krista here. And then if after that I would call count calls, which holds the property of call times, I would get 2, but we have console.log that really. Or we can just do something like this, console.log count calls called times. And it will work as expected. It will be 1 first because after it became 0, we added 1 to it, and then it will be 2. So if we add another, say, name with count calls, it will be 3 already. So I already wrapped my function inside of something. And another thing I want to mention here is what if I don't have just statically written Krista? For example, if that function takes a name and I want to console.log hello and then pass name here. What should I do in this case? Because from where I should actually pass an argument inside of it. I have my function here, right? So say name is passed as this. So basically what I should do is I should pass an argument here. And then I should call the function which I provided from here. So I should pass an argument. And that's how it works. When I'm declaring this function becomes function which was returned from our first wrapper function. So that function now accepts an argument. So it's easy to say that here I can easily pass any argument. So for example, the first name will be Krista, the next will be Mariam, let's say, and something like Nick. On every calling, we are getting the same example. Why? Because actually, the function argument which is provided here calls the function which was provided as an argument to the wrapper one is called like sequentially. So for now, the most important part we should all understand is that functions, and it's like in functional programming language, it's pretty much essential because we expect functions to receive another functions as an argument, because all of the asynchronous principles are written by this statement, and it's really essential to understand how everything works. Let's go deep on this. So we already saw an example where we had an object. I'm just rewriting everything I said here, and I'm saying that the radius of an object radius will be something like 12, and the shape will be circle. And then we say that we can pass a function as a method of an object. So basically, I'm saying that the regular method is equal to function which console.logs this. As I explained it in the previous lecture, if I call a regular method on this, I will receive a object with deep this actually, so it will have radius and shape. That's why I can call it by console.log radius or console.log this shape. Why? Because the function understands where it was called from. So it takes the object from left side of the dot, and it replaces this by object with deep this. And that's why this object actually has a property inside of it. We already discussed that. But the thing I want to highlight right now is that, like, let's just make sure that it works. Node this.js, and we are receiving the object itself, because this at this moment is just object with deep this, which has radius, shape, and the function itself. But what if I declare another function inside of this one? So I'm saying that const inner function is equal to function which should console.log log this. At this point, I should call it down here inner function. So the first console.log does everything like straightforwardly. It knows that it was declared as a method of an object, and this at this point is the object itself. But the inner function doesn't really knows that it's inside of any object. It doesn't see the object itself. It just assumes that it is written inside of another function, and that's why this is just a global object. It would be window in browser environment. As I told you, the global objects are different depending on the environment we are running them, and for browser, it would be just window. So the function doesn't understand where to take this from, and it assumes that it's just a function, takes it from the global context. To solve that problem, we can reassign this. So how is it done? So I know that at this point in this statement, outside of our inner function, this is equal to object with deep this itself. So I can say that const right context is equal to this. So now I saved my value of this inside of this variable. And here instead of saying console.log this, I would say console.log write context. And if I say that again, I will get an error, not sure why, unexpected token, because we don't need that here. So now in both cases, if I expand my console, I will have this. So this will be the same here and here as well, because we implicitly passed it like this. So now I can call the properties of an object regularly. So write context radius, and it will give me the radius itself. So it will be 12 at this point. This is a big issue because it is leading to a lot of errors, because sometimes we are expecting the function to understand where it was called from, but it really does not. So we can't really identify where it was called. And we have an instance which will help us with that, but let's talk about that a bit later. Firstly, I want to move to the arrow functions. So I already told you that arrow functions is just a syntaxis of writing functions which doesn't have any arguments. So we can call arguments. You could see that in the previous lecture, and which has a different syntax. So this example is the one we already seen. Let's move that down. We don't need that at this point. Well, basically, I have a function which is passed as as a parameter of two objects. And here I'm calling that function. That's pretty much it. So I have John and Mary, and I passed this function down to the both objects. Even though console.log says that John say name and Mary say name is absolutely the same function, so I would get true here. It's interpreted differently. So this one takes this from John and this one takes this from Mary. So at this point, we need to understand that this is determined when the function is called. So when it reads the code of calling, right, it sees the parenthesis, it assumes that it was called on John. Only at this point, this is assigned to say name. Before that, we don't know what this is. But the arrow functions are pretty much different in this context. If I say that this function, so it's absolutely the same actually, because I'm just saying say name with arrow, it receives non-argument as this function, and it console.logs this. So it does pretty much the same, but with arrow function syntax. And here I will pass. So instead of passing just a function, I'm passing, say, name arrow here, and I'm calling it as well. So why I mentioned on the previous lecture that arrow functions don't have their own this. So if regular functions are taking this as an argument when it's called, arrow functions are determining this when they are declared. So it doesn't really cares from where do we call it. For example, if I run this function now, I will get two empty objects. True is coming from this line when I'm comparing two lines. So basically, I'm receiving two empty objects. If I would do that in the browser environment, it would just link me to the window. Why? Because arrow functions it is determined this here. And this is already written inside of it. It understands that it was declared just in global scope. That's why this is saved to global. So at this point, this function just doesn't really cares from where it will be called. It just knows that it was declared here and it takes this from the global itself. This approach of arrow functions is solving a lot of problems, but it can create one as well. So for example, here we wanted it to have this take it from the object before the dot, but it actually took this from the global object itself. Let me show you the use case of arrow functions. So in the previous example, we had to redefine the context provided here. Why? Because this function, inner function, has its own this, and it is replaced, and it replaces every other this. But if we would do the same with arrow function, so if I remove the name, if I do arrow here, if I remove arrow brackets from everywhere, right now, as I said, arrow functions are taking their this from where they were declared. So this function is declared from here, right? And what is this here? This is pointing to the object with deep this. And since arrow function is declared here, where this equals to object with deep this, arrow function will take this from outer scope. So it basically borrows this from its parent. That's how I can name it. And if we run that once again, node this JS. So now we are getting everything straight. So now we don't have to reassign this. Now we don't have to move it to the some kind of a variable. Now it just works because it already knows what this is. It don't need any hint from where to call or what to take as in this. It just borrows it. As simple as that. What I want to mention actually that you will mess up with this. I mean, everyone mess up this from like it's like mandatory. You won't learn it if you don't break it once. I can like guarantee that everyone did that because in some other examples, in some more complex ones, when you are dealing with asynchronous code, for example, it's pretty much easy to forget what is your this and where to use arrow function when to not. But for now, just example that just remember that arrow functions are um, having their this at the moment they are declared, and the regular functions are receiving this at the moment they are called. That's what I want to highlight for now. And after that, I want to move to the scope. And scope is an interesting thing, but it's actually pretty easy to understand in terms of JavaScript because, well, I'll explain it. I have a variable outside. So it's just a variable which is assigned to 5, and I have a function, just comment that out. And I'm console.logging some var. I have a variable and I'm trying to reach it from inside of the function. If I execute this code, I will get 5. Why? Because some variable is defined in the global scope, and that means that every single function in our code will see it. So basically, scope is a place in our code where the variable is seen. Since some variable is in the global scope, everything can reach it. But if I move it down here, console.log will work. So why it will work? Because it's console.log inside of my function, and some variable is declared like inside of that too. But I cannot reach that variable from here. If I just say console.log some var, it will give me an error because somewhere is not defined. It is visible just inside of our function. So that's basically what scoping is. Scoping is places in our code where the variables are seen. That's pretty much it. I mean, that's the scope. And we have two types of scopes. The first one is lexical scope or static scope, in other words, and the next one is the dynamic scope. Let me point out that in JavaScript, compared to all other languages, we pretty much have just static scope. So the only thing which is not defined statically is this. Let me show you the example. So I have car here. It's defined globally and it's BMW 3 Series 3, which is great. And I have a function which console.logs this car. And later I declared a function which will tell me about my specific car, and it's model 5. So I have two variables, they are named the same, and they are referring to different objects. And from here I'm calling the function tell about car. So again, what is static scope? Static scope is something which I can really understand if I look at my code. What I mean by that, let's imagine, so static scope is determined at the moment it was declared. So if it was determined, if it would be determined at the moment when it was actually called, then the car would be the next car because this function is called from here, right? And when we are looking for car, we assume that the interpreter would come here. because it's called from here, and that means that the car would be this object. But if we run our code, we will see that actually the object is this. Why? Because when we declared this function, scope was already determined. So the function already knew where the car can be found. So firstly, it searched for the car inside of the function itself. And when it didn't find anything, it gets up and the car became the model series 3. So what I want to say is that mostly everything in our JavaScript except this is defined, then the function is declared. So in this example, we didn't knew about anything about from where our function will be called. The interpreter didn't knew that it will be called from here, and that's why car is taken from here instead of here. And dynamic scope is something which we already were talking about on the previous lecture. It's just two objects which have uh, which are taking a function as a parameter, and when we are logging object 1 with same name and object 2 with same name, it's dynamic scope. Why? Because now the scope is determined in the context, so it's depending on the object we are calling it. So basically, if you can really understand without calling how the function, what context will the function have, it means that it's statical scope. And if you depend on the object where it's calling, it's dynamic scope. As simple as that. You will probably understand more about scope when we proceed, and with some practice it will become like the second nature and it will be simple to understand. So we know what functions are and we know what scopes are. And that leads us to the closure. And closure is exactly functions plus lexical environment, lexical scope. So closure is something which knows about the function itself and the variables of that function can accept. So what is scope here is that I have a function, say secret name, and I have declared a variable inside of it. And that variable is mark. It's closured. Why it is closured? Because this function, which wants to console.log secret name, firstly search for secret name inside of itself, and it doesn't find anything, and then it goes up and searches from here, and boom, it's found. So we found mark, and then if we let me remove everything else. If we say that say name is say secret name, this function will remember that the secret name once was declared as mark, and it will always console.log if we call say name for this point, it will always console.log secret name. So for example, if I node closure here, it will say mark, and it will say mark on every time we call it. Basically, it's not called secret just for the example. It's a good method of encapsulation. For example, I want it to always be marked. I don't want someone to reach this variable from anywhere, basically. And I can't. I can't just say that, say secret name dot mark, because it's not a property. It's just a variable which is are remembered by the function which we return, and that's why it's not it's immutable. Basically, we can't redefine it more times. I mean, because it's already closured. Same as variables, arguments are closured too. So, for example, if I have wrapper function which accepts greetings, and I have another function which accepts something to greet, and I'm console.logging both greeting from outer function and something to greet from the function itself, it will remember that. So, for example, if I say greet world will equal to wrapper function, and here I'm providing the greeting itself. So let's rename it to greet with hello, and I'm saying that you should always greet people with hello. It will remember that this argument is always hello. So never mind how many times we are calling greet with hello. It will always be hello. And here I can just pass another argument, which will be world. And if I call that, we will have hello world, because the first argument is taken from the wrapper function, which is hello, and the second argument is read from here, which is world. If I say greet with hello, I don't know, universe, I would get hello as well, because hello is already closured, it's already remembered by the function, and it's always hello. The universe just will concat by two names, so the second function is getting universe as its argument, and it will be just put it together and give us the hello universe at the end. Uh, this is pretty much useful examples because there is a lot of use cases where we should really decorate our function. And function decoration is actually something which extends the abilities of the function. So let's imagine that we have, say, name here, which accept names as a parameter, and is just returning us hello and the name. And here I'm declaring function decorator. So decorator is something which takes base function and returns another function, but with decorated values. So here I want to know how many times the name was said. So I'm returning the function, and I already mentioned what is REST operator on the previous lecture, but here this is not the REST operator. So basically, when we see syntax with three dots and some name of the variable, it can mean two things. First thing, that it's REST operator. So let me move it here. So we see that the REST operator is inside of function argument. If we see three dot syntax inside of declaration of the function, it means that it's REST operator. But if we see three dots in anywhere else in our code, it's spread operator. What does that mean? At this point, arguments takes all the arguments which were passed here, right? So for example, if I would had arguments as 1, 2, 3, 4, the spread operator would take that all of them and put them in array. So at this point, args is referring to the array. So it took my arguments and passed every value of that arguments inside of an array. But at this point, I want to do the opposite. So I passed say name function here. So this function is basically say name because that's how I passed it. And I don't expect this function. This function just accepts name and not the array of the names, right? That's why I'm spreading it. So basically, at this moment, args equals to 1, 2, 3, 4, for example, and it just puts everything out of an array. So I'm getting 1, 2, 3, 4. In our example, I'm firstly calling John, then Rebecca, then Sam. So at first it will be John, for example, John, and John becomes the first element of an array. And after that, then we actually spread it. John was the array firstly, and it came back to the just John because that's how we expect our name. So if you would have an argument here, then just args would work. And decoration is something which you will probably once more told about when you will learn something like design patterns, because it's pretty much popular decision on how to expand the functionality of our function. For example, there is pretty much useful one when we are determining if function was called before that, and we are kind of memoizing the value of it. But it's pretty much complex. We don't need that at this point. Just remember that the variables are closured. So they are remembered from here, and we can pass arguments inside of our function which we return. That's the main purpose of decoration here. It was the main part, and then I want to show you what shadowing is. We can refine, so when we know what is scope about, we can easily understand what is happening here. So basically I have a variable and I want to console.log shadowed variable. But note that this variable is declared both in global scope and in the inner scope. So which one will be run? As I said, then I'm console.logging something. Firstly, it search inside of the function itself. So it sees that the shadowed already exists inside, so it will be 5. It won't go up because it already found it. So basically, shadows is referenced to this line. And that's why console.log shadowed will give me 5 instead of 2. But that is not only limited to the functions themselves. We can easily put if block here. I just put true, so it's always executed, and then I'm just letting shadow be 12. Note that we can everything which is starting with curly brackets is scoped. So shadowed for this moment will be just it's not an error that we're reassigning something. Even if it would be const, it wouldn't make any difference because it's different scopes. For this console.log, for this block, the scope is just the block itself. It doesn't need to go up to the chain to search for something because shadowed is 12 for at this moment. For example, if I call um, shadowing.js, the first thing you may notice is that the first thing is 12 because console.log shadowed shows me the shadowed itself. And the second one is 5 because it console.log shadows from here. We don't need this console.log really. So first console.logs gives me 12 because it's inside of the block where shadowed exists and it's referenced to 12. And out of this block, console.log is referenced to 5. It's pretty much easy to understand. Nothing is redefined here, and it just finds for the closest relative, like firstly here, then here, then here. If I would remove this and this, it would search for a shadowed variable firstly here, then it would go up here, and then it would wouldn't find it, and it would go to the global scope. If this doesn't exist, it will throw an error because it didn't found anything, which is pretty much logical. Not logical. So, statement should find a variable, and it will go up to the chain until it finds it, or it will throw an error. Another thing I want to mention today is chaining. So we have an object which has a property of value. And I have plus, I have minus, and I have show. So plus just takes a number and it adds a value to, so adds the argument to the value, right? And it's pretty much simple. So for example, at first it's 0, I'm calling plus 3, so it will go here. It's taking 3 as an argument, and it will say that this value, which is 0, plus equals to num. So basically it will become 3. Then I say plus again, I'm plussing 12 to the value, and it will be 15 at this moment. Then I'm saying minus, it just subtracts the value we provided from the value, and at the end of it, we are saying that the chaining just returns the 13 from here, right? So what I want to point out from that, I don't need the second show. So it's just 13 because firstly it's added plus, then it's added 12, then it's added minus, and then it just showed which is console.log this value. But this is pretty much uncomfortable for both reading and writing. So I want this to happen. I want to say that object for chaining plus 3 plus 12 minus 2 show. It's much better to read. It's logical to have it here because everything is chained for now. I can call as many methods as I want. I can put 4 more methods here. But what will happen? It will give me an error actually. Give me an error that I cannot read property plus of undefined. Why undefined? Because then I called first object for chaining dot plus. It went here, right? Remember on the previous lecture, I said that if we do not explicitly say return something, it will just return undefined. So I executed the first plus and it returned it undefined to me. So this statement became undefined. And when I try to call undefined dot plus 12, of course, we don't have plus method on undefined, and that's why the error is shown. So let's think what we can do to return the correct value from here. So it would have our plus here. And the answer is this. If on every method we return this, it will actually give me the correct value. Let's sub plus of undefined. Yes, so I have to remove that object for chaining dot plus 3. So now it will actually work. Why? Because when I called object for chaining dot plus, so it returned something, right? We now want it to return this, and this is object for chaining itself. What does that mean? It means that instead of this statement, we got to the object for chaining. Then we called plus on object for chaining one more times, and it's still replaced with object for chaining because that's what is returned from the function. And then we have minus. Again, returning of this statement gave me object for chaining, and then I finally have show, and after that just this value is console.logged. It's pretty popular decision to have if all of the methods affect just one value or several values, it's pretty much simple to prefer this approach to this. Because first of all, it's less writing, it's more like understandable for an eye, and it's really simple to just proceed it in the chain. So what's what chaining is? You will probably asked about that on your interviews. So basically, chaining is when the methods of an object can return the method itself. So it is returning this. So next, I could run any other method on top of the method which was on top of the object which was returned. Uh, yes, I consider this one the most simple example, but it's really classical. I mean, you do not have to understand anything beyond this when it comes to the chaining. Um, that's pretty much everything I wanted to say today, but I assume that you would have questions and I assume that you will ask them so we can run like one more time on the topic which became most difficult to understand. I expect it to be closure or decoration, so don't hesitate to ask questions because it is really a difficult topic. Also, I want to mention that there is a great articles I found, and they are that articles are actually a series of articles, and they're there are example of in depth of how everything that is read by the under the hood, so how interpreter understands it. I will provide the links in the Discord along with the code snippets themselves. So let's turn back to the chat, and that's the right moment to start Q&A. So you can go ahead and ask any question you have. Yes, so closure, let me go back to the closure itself. So closure is something that so basically closured value is value which is remembered by the function. So function plus lexical scope of it gives us the closure in result. So closure is an ability of a function to remember where it was called. So now for now, when this function is returned, this function remembers that we had secret name somewhere. We had secret name somewhere where this function was declared. So Right now, this mark is binded to this function because this function actually remembered the context of its execution. So it saw that the secret name is inside of its lexical environment, and it will point to it always. So as many times as we want. Um, when we are returning something, it's just an anonymous function, remember. It finds secret name in the place where it was declared. So that means that this variable is binded to this function for good. It will always remember it. It's the method of encapsulation. I don't know if that term is understood by you, but it's something. So basically, it's secret property. We cannot change it, and that's basically how closure is used. We encapsulated this mark inside of this function, so it won't change in any case. It will always be mark. For example, now if I say mark, or do something different. Let's make this function to have an argument of name, and I'm saying that secret name is passed as an argument of here. So I want to make function which will call mark only on every single call. I'm declaring a function which will be called say mark, and I'm assuming that this function is say secret name, and I'm passing mark here, but with string, of course. When I'm calling, say, Mark, it will always say the name of Mark. Why? Because this function was initially created with this name, and that means that console.log will always return the secret name for us. And I cannot change that. I can't access something which is closured inside of the function. So by this method, I'm guaranteed that the name won't change in any scenarios. To say any other name, I would do something like on say Nick. And I would say equals to say secret name. And I would say Nick here, and say Nick. Absolutely different function for this moment. So this say mark received a name inside of it, and it's pretty much remembers the value with which it was created. And that's why I'm guaranteed that say mark will give me the name of Mark, and the say Nick will give me the name of Nick. So that's what basically scoping is. Scoping is an ability of function to remember which lexical environment to use. So where to access our variable. So when we copy a callback function outside of its environment, it takes as binded variable with it, correct? So obligatory to copy in global scope. So we don't really, of course, so what am I saying here is that it's obligatory to redefine this function because we do have returning the function, right? So if we um, if we wouldn't declare a global variable for that, it just wouldn't work. Why? Because the function, say secret name, returns a function, which returns the console.log. So if I wouldn't have any variable here, I wouldn't be able to call inner function. So basically, say mark is the insider function which returned from this value. So let's make it clear. When we call say secret name with parentheses with mark, right? The function is returned. So for example, if I console.log, let me remove this, console.log, say mark. So I have an anonymous function here. Why? Because so basically say mark is this function, which is anonymous. We don't have any name here. And to call that function, we actually have to provide a parenthesis to it. So we have to call this function twice. I could do something different. For example, I could say secret name. I would provide a mark here, and then I would add another parenthesis. Why? Because this statement gives me the function, right? So this is what will be returned. And then this function has to be called one more time, right? Because we want it to execute, not to just exist. And this is absolutely the same example. So it will do, it will like work as supposed. But yes, we have to declare a variable somewhere because say secret name doesn't really does anything except it's called twice. One for the say secret name itself and one for the function which is returned. Do you have an idea of what I talked about? I mean, do you understand now? Uh, can you show us chained object? Yes, so chained objects are somewhere here. Is there a moment like which you do not understand from this example? So I could explain it one more time. This keyword refers to the execution context. So basically, this is something which is, let me get back to the example. Um, this is something which is which determines the object. So I had an example somewhere here. So this is referred to the object from where the function was called. For example, in this example, both are receiving this name, and the when it is called on the object one, so this function is passed both as a property of object one and object two, and this is referring to the object where it was called. So for this function, this refers to the object one, which has name of max, and this function has this as the object two. So this is something which this so basically this is an object, and it's not the parent because parent can be a function, parent can be a global scope. So this is something from where the function is called. Basically, that's how can we simply understand that. Optional chaining, it's not much used, and optional chaining is basically um, how to say, exemptional. I don't think it really works on every example. So optional chaining may have some good examples. Let me. And what I'm interested. What do you mean by the optional chaining? So it's some instance which can be called with which. So basically, this is an optional chaining as well because it can be. Where do I had here? So it can be run this way. So I can run plus on the object itself, but I can not. So if that's what you mean by object, mm, by optional chaining, that's basically it. So you may or may not call it so chainfully because this example would work as well. But if you mean that we have if statements inside of our functions which are determining if we have this or we don't have them, it's like a different story and it's much more complex example, and I don't think it will really that much useful for you. Yes, so basically, question mark operator is something which, how to say that? So, for example, in this case, let me show you that example exactly. What is done here? Here, I may get an error. So I showed you that if we do not have returned this, it will give me an error. Why? Because, for example, plus would work. Why it would work? Because after we are calling plus here, it is replaced by the object for chaining. So this would work out here. But when we say minus, I remove the return this from here. It will give me the error. Why? Because it will be an undefined. So question mark is something which just will return an undefined here. So it's something, it's written like this, and it's pretty much new syntax. We didn't had that in the previous version before. I don't remember which ECMAScript it was, but it just prevents an error. So it's making sure that if minus, so it's if it's undefined. So for example, if I have plus here, example 12, I can put question mark here and say that if plus doesn't exist, if this doesn't exist on that, I can just not throw an error, but just return undefined. So in this case, undefined will be returned and not an error. So that's everything about optional chaining. So basically, when we are writing question marks, we say that don't keep going if you received an undefined. So if you saw an undefined here, just leave it. Just make the whole statement return undefined. And that's kind of useful thing in some cases, especially on the React. It's used a lot because we may have some property of Redux, for example, and we may not. But for chaining, it's how to say. I never encountered it in real life, but the question mark operator itself is really, really useful. And what it does, it just prevents us to getting errors. So once again, we are just checking if plus exists on the return of the previous statement. So it's checking if this gave us an undefined, stop. If it did not, so just keep going and try another method. And then we like say question mark once again. It just checks for the minus. If minus does not exist, if we did not return this from here, it will just stop. It will return undefined, something like that. Any other questions if I answered like properly? Yes, again, so all the code snippets will be provided along with maybe optional chaining if you are really interested in that topic, even though it's not that much of popular. But yes, it exists, and it's a valid example of how to prevent some kind of errors when we change something up. And that's a great thing that you mentioned it. Do you guys have any more questions about like all the topics? Uh, I'm not sure if I'm really well. I have a big knowledge about some organizational topics, so I may not be sure. For example, where should you create branches when you're doing tasks, or where you should like what is your deadlines. But if you will have any questions about like technical topics about JavaScript or front end in general, you can not hesitate to ask me. Like in direct in Teams, probably because that's the place I check the most. I am in your Discord server, but I'm not sure that I will be available there, so Teams is preferable. So if we do not have any question, let's stop the meeting at this point. Code snippet, as I said, will be uploaded, and have a great day, everyone. Bye.
Thank you. It was a great lecture.
Thank you.